Hi everyone, I'm Kevin Rolling. I'm a forestry research technician, also with U of I Extension Forestry. And I'm going to talk a little today about how to navigate in the backcountry. And my original intention with this was for folks to be able to kind of follow along and kind of be able to look at some of these maps and features as we're discussing them. And I came to realize there's probably more content than will allow for a whole lot of interactivity. So please don't get too frustrated with me, but just know that you can always go back and rewatch and kind of take some of these tips and practice on your own. So just an outline of what we're going to go over today, some basic tips, different types of maps that you'll come across. I saw a lot of you are from kind of scattered all over the state, and this presentation is somewhat Southern Illinois centric, but hopefully you can find similar types of maps for wherever you are in the state or elsewhere. We're going to go over different components of maps, compass parts and how to use them, how to use the map and compass together, and then we're going to close out with Avenza Maps, a navigation app that we use pretty frequently down here. So first tip, don't get lost. Yeah, always bring a map and compass wherever you go. I have a brief story I might share at the very end about getting lost and how we would have been fine had we had even the most basic map. But as it turned out, we had quite an unnecessary adventure. But definitely want to bring that along. GPS devices, phone applications like we're going to talk about today are incredibly useful and make navigation a lot easier versus using map and compass. I kind of see map and compass as a backup to these electronic devices just because they're so much more easy to use and allow for more time to explore. Always tell someone where you will be and when you plan to return, just in case you do get lost. Somebody knows generally where to look for you. And pack a little bit extra supplies, never a bad idea. So to jump right into some of these different types of maps, this is just sort of a general site map. I saw several folks mention Fern Cliff State Park as one of their favorite places to hike. In these developed areas like Fern Cliff or Giant City, you may not need a whole lot of details in your map. There are a lot of roads, there's a lot of trails. Of course, you can kind of get mixed up in your trails, but it'd be pretty hard to get significantly lost in some of these more well-developed sites. So this type of map might be just fine for getting around a site like that. But sometimes you want a little more detail, want to be able to read the landscape a little better, see what's ahead of you on the trail, or if you're going off trail bushwhacking, what's going to be up ahead. And so for Fern Cliff, you might also choose to either download or print out a topographic map. So I'm going to talk a little bit more about Topo Maps coming up, so I don't want to ruin that. But it's sometimes better to have multiple options. So as far as topo maps, topographic maps, these are generally the gold standard for navigation. This type of map is detailed enough that it allows for easy visualization of landscape features and for allowing for compass readings that you can line up with some of the lines on the map and triangulate your location, which we'll talk about here in a little bit. These are typically pretty standard, 7.5 minutes, 7.5 minutes referring to the amount of latitude and longitude that are covered by these maps. The contour lines are going to show your elevation These maps typically have named landscape features and landmarks in some cases. And in addition to lat and long, they also have these additional grid systems such as Universal Transverse Mercator and the Public Land Survey System marked on there. So where do you find Topo Maps? So depending on your area, it's going to vary. These Forest Service topographic maps are highly recommended if you're anywhere within a national forest or even in some of these adjacent areas. You might be able to scoot in there. Even if it's not on the national forest, you might be able to pick up your site outside of the national forest if it's within one of these blocks. So those are available online. I have links to those websites here on this slide and then at the end as well. If you're not anywhere near a Forest Service site, you can also look up the U.S. Geological Survey maps, which cover the entirety of the U.S. And the website link there is where you can find those for USGS here at the bottom. Those typically will not have the trails marked on the maps. So that's one of the really big benefits of these U.S. Forest Service topos and compared to the USGS. Other types of maps you might come across. So different states are going to have different types of site maps. We saw that Fern Cliff one earlier. You go to Missouri, they're going to have slightly different site maps. This one here is a Forest Service recreation map that you can find for the more developed portions of, for example, the Shawnee National Forest. I'm not sure if that's the case for every national forest, but for us down here, the more developed areas, you can find these kind of general guides, and they'll have these they have information with both general info, but then they also have these topographic lines and the contour lines that are going to be helpful for navigation. So these are really nice if you're in those sorts of areas. So up next, we're going to get into a little bit about reading these topographic maps. So of course, like any map, you're going to have various symbols and you're going to have a legend. So I kind of blew up here the bottom of the topographic map. So this information down at the base of this topo map. And you can see there's a lot of different information here. So you have different types of lines for highways versus unimproved roads and so on. The scale, of course, is going to be important for being able to measure distances between points that you're navigating to and from. The scale of these 7.5 minute quadrangles is 1 to 24,000, which basically means that 1 inch on the map is equal to 24,000 inches in the real world, or 2,000 feet. All right, so the scale and scale bar, like I just said, are going to be useful for calculating those distances. There is a little graphic here on the left that shows the difference between geographic north and magnetic north and grid north. So that gets to be a fairly confusing concept. I have another slide on that coming up. So with that kind of first tip in mind, as far as not getting lost, it's a good idea just to get used to just checking your progress as you go along. And that's true for just using a paper map or a navigation app, just to make sure you are where you think you are. And if you get into the habit, you're not going to get too far off the beaten path. Good way to do this is to check at trail intersections, waterways, and features that you come across. Of course, these intersections, you might see something like this, where it's not exactly clear which direction you're supposed to be going. But if you think about your direction of travel, and you kind of have your map or your route planned out, you'll know which trail to take if it's a split. You might be traveling north and think, okay, I'm going to continue towards the northwest. I know I'm going to have to take this left. You might also come across these types of signs if you're in the Shawnee. So these are kind of unofficial signage that I've seen in several places. I think these are often put up by equestrian users, especially in places where it's not already clear. But these can be difficult to follow, kind of unofficial descriptions. So long way to the Garden of the Gods, access to the River to River Trail. Actually, you can access the River to River Trail going in multiple directions here at this intersection in particular. Giant overlook. So not always easy to follow. But if you start to learn how to read a map, and you can kind of visualize different features on the landscape. So especially if you're following a trail, you shouldn't typically have to use your compass. So up next, we're kind of going to look at some of those landscape features and how they show up on a topographic map, and how you can relate that to what you're seeing on the landscape. So first up are general description of contour lines. So the lines indicate an elevation change. So these are your elevation above sea level, and the closer the lines are to each other, the steeper the terrain is. So you can see here this little cutout of Womble Mountain. This is also on the Garden of the Gods topo quad. But you can kind of see where the lines are close together. This might actually be more of a cliff face where those lines are closest, and then this is going to be a much more gradual decline or incline where the lines are spread farther apart. And just kind of an interesting side note here, this Garden of the Gods quad has the tallest point in southern Illinois, Williams Hill at 1,064 feet, and then kind of the lowest point on that quadrangle is the Big Grand Pierre Creek at 360 feet. So probably some of the most significant topography differences that you come across in the state. It's kind of cool. So following on that, some of the landscape features that you can start to identify using these contour lines. First up are hilltops. This, of course, is going to be pretty useful when you're using your compass to try to figure out where you're at. These hilltops are going to be very visible generally relative to other landscape features. And you'll know a hilltop because of the kind of circular series of contour lines. There aren't many other landscape features that are going to have that look in their topo lines. Perhaps circular depressions such as large sinkholes, but they'd have to be quite large for that to show up. Up next, another landscape feature you might see are saddles. So areas that are between two hills or mountains that kind of maintain a higher elevation above the base of those hills or mountains. And so you have kind of a visual here on the right of what a saddle might look like on your topo map, where the elevation doesn't decline all the way between those two hills, and the same feature kind of looking out on the landscape. And this could be useful for navigation, where perhaps you are wanting, let's say you're on the west side of this image near this creek, and you want to get over to this side on this creek. kind of the easiest route might be to walk all the way around the outside. That way you don't have to climb up the hill much at all. But an alternative might be quicker, just to go up through the saddle and get through there. That way you're not climbing over the topmost part, but also not going all the long way around. So that could be useful when you're kind of planning out a route. Cliffs, I already kind of mentioned this though, but the contour lines are just going to be pretty tightly together, compact. And these may or may not be something that you're able to climb up, especially some places kind of on the west side of the Shawnee, near Snake Road. There's very few places you can get down that cliff face. So that's something to consider when you're navigating. Here's another kind of concept, looking at valleys and drainages and ridges, spurs, how these landscape features show up on topographic maps. Both of them kind of have this V shape to them. So in terms of a valley or a drainage, that's what we have here in this pictured on the right. The V points towards the higher elevation. And kind of the opposite is true for the ridges or spurs, where you're kind of declining from a hilltop. The V is going to point to lower elevation. So it's a little more complex, but something you kind of get used to the more you read maps. Water features, these can be really good checks on kind of where you're at along your route. Obviously, ponds are going to show up if they're of any size on the topographic map. And then on the right, you have kind of this intermittent stream. Streams that are running regularly will be a complete line here. This line here is kind of broken up by these dots and dashes. That means there's not going to be water running in those year round necessarily. So we have a slide here on coordinate systems. I'm not going to spend a huge amount of time on this. Just know that there are multiple coordinate systems that are indicated on these topographic maps. The first here is latitude and longitude, and those are indicated by these black circles. There's very few markings for the lat and long on these. So each of the corners, and then there's a couple very small markings on the top and bottom of the topographic map. One thing that the lat and long are useful for here is just kind of determining the eastern and western and north and south extent of each of these topographic maps. So they're called 7.5 minute quads because that is the north, south, east, west extent. So 7.5 minutes of latitude and longitude, both north, south, and east, west. And the other reason we use lat and long on in terms of our navigation, as far as what we're going to talk about, is the edges of the map. So the edges of this map are what we're going to use to align our compass when we get to that compass part. So these internal grids, if you look at the UTM marks, the UTMs are marked by these yellow circles, and internally they are kind of these yellow lines. And then if you look at the public land survey system, that is indicated by these red lines and these red numbers. Those can get you kind of confused when we're using the compass to navigate the way we're doing it anyway. You're going to line your compass orienting lines up parallel to the edge of the map, which the edge of the map is that degree of longitude. So it's kind of difficult to do once you get kind of away from that edge, because the lines of longitude don't extend across the entirety of the map, across the whole width. So you might actually need to draw in another parallel somewhere so that you're better able to line up your compass. You don't want to use these. You can kind of see how the red and the yellow kind of depart at different angles from the Latin long. And there's a lot more that we could talk about as far as these are concerned, but that's kind of all we have time for in this short amount of time. So from there, we're going to talk a little more on the compass. And so in terms of navigation, probably the best type of compass are these that have the clear base. The type that you see here have this reflective mirror that kind of helps you hold the compass kind of up to your eye level and get a more accurate reading versus the type that don't have the mirror. And I have another slide with those types on it as well. And then the mirror also doubles as a signal mirror, which is another one of the things that you see recommended to bring along on hikes and backpacks as sort of a survival gear. So another thing you might consider when choosing a compass is the declination adjustment, and we haven't gotten into that yet, but the difference between the magnetic north and the true north can get confusing when you have to add or subtract that declination from your readings. But some compasses allow you to make that adjustment, and you basically can just go from taking your reading on your compass to taking that same reading and using it on your map. And you don't have to do the math in between, which can be really helpful. So it's something to consider. It is a little more money for that type of compass, and then there are a lot of other options out there. If you start researching compasses, if you're thinking about making a purchase, depending on your needs, some of the most basic ones are probably more than adequate, but there are lots of bells and whistles that you might consider if you're going to be using it a lot. So here's the other kind of similar type of compass with clear base, but instead of having that mirror, you have this direction of travel arrow. So you wouldn't necessarily hold it up right in front of your face. You kind of hold it out kind of more in front of you and point that direction of travel arrow toward the landscape feature that you're trying to measure your bearing or azimuth to. So not quite as accurate. Another thing that's not quite as accurate about this particular compass is there are fewer marks along the compass housing. So you kind of have to guesstimate if it's in between these little five degree difference marks. But anyway, a couple of differences there. Pretty much every compass of these two styles are going to have some type of ruler. In this case, it has millimeters, but a lot of our maps are based on English units. So some better compasses will have both metric and English. Some also have an extra ruler for measuring UTM differences in distance. But that's getting into the more serious bells and whistles that we were talking about. Another The next component of compass that we'll talk about is kind of the base plate. So basically this whole uh, bottom part of the compass is the base plate, the direction of travel arrow. The compass housing is this dial. The orienting arrow is the arrow that's within the compass housing, not to be confused with the direction of travel arrow. This is the orienting arrow. And also within the compass housing are these orienting lines. And that's kind of what I was starting to talk about earlier when we were talking about taking those angles from the landscape and lining them up on your map. And we'll do a couple examples of that here in a minute. But then, of course, there's the magnetic needle. So, got everything? There's a lot involved here. Here's another concept that can be a little challenging. So what we have here is many of you probably are aware that magnetic north is always changing. So actually in more recent years, it's been changing more rapidly. So that is something you need to consider. Although if you look at this diagram here, this shows you how many degrees difference between magnetic north and true north on your map. And we actually fall pretty darn close to no difference where we're at here in Southern Illinois. But if you go farther to the west or east, you're looking at up to 20 degrees difference between magnetic north and true north. And that difference is going to make a huge difference in what you're reading from your compass and what your angles are going to look like on your map. So definitely something you want to think about. And I mentioned earlier, at the bottom of those topo maps, there is this declination diagram that shows you exactly how many degrees off from true north is magnetic north. So in this case, it was 2 degrees and 45 minutes. So almost 3 full degrees. This was taken in 2019. I actually looked it up. You can use this link to look up current declinations for whatever location you're looking at. And it's a little closer to 3 degrees. So it moved a few minutes, but not quite a full degree since 2019. Like I said earlier, the easiest way to deal with this is to get a compass that allows for this setting, and you don't have to do any math once you get it set. So that's really handy. But if you don't have that type of compass and you want to still do this, you will subtract the value on the declination diagram if it's on the left side of the diagram from the azimuth taken on your compass. So, you know, if we were in a different area and the declination were on the right side of true north, then you would add the value. And that's as much as we're going to talk about today on that. So now we're going to talk about taking an azimuth. And I kind of interchange azimuth with bearing, but that's not exactly correct. This diagram here at the top shows that bearings are actually divided into 4 different quadrants. So they're going to go from 0 to 90 degrees within each 4 portions of a compass. So what we're actually doing is taking azimuth. So between 0 and 360 degrees. True north is, or magnetic north is going to show up to 0 or 360 degrees. So what we're doing when we're taking an azimuth is we're actually taking an angle from where we're located to the landmark that we're pointing at relative to magnetic north. So generally we're looking at measurements between 0 and 360. And what we're going to do is we're going to identify landscape features on our map that we can also identify on the landscape where we're looking on the horizon. And then we're going to point our compass, the direction of travel arrow, or this little V notch on the mirrored type, directly at that feature. And when we do that, we're then going to rotate that compass housing around until the magnetic north needle is in line with our orienting arrow. And I believe up next I have one of the videos. So I'm going to try and switch my view. Let's see how this goes.
Okay, so trying to get a read of the land. We already kind of know where we are, but looking on the horizon, kind of matched up a couple of these hills with some points on the map, at least that I suspect. So getting the compass out, and we're going to direct the center point of the compass to the tops of those hills. And as the saying goes, you want to put the red in the shed. So you're going to rotate the compass to the point so there will be our first reading to that hilltop right there. So once you put the red in the shed, come back and take your compass bearing, and you can see it is at 172 degrees. So we're going to write that down, 172. So this compass does not have the mirror to kind of get a more accurate reading, but it should still be good enough for us to get pretty close. So once again, we're going to be pointing the direction of travel arrow this time at the landscape feature, and we're going to rotate our housing to align the needle with the arrow. And looks like we have it right about there. And let's see, in this case looks like we have 335, so pretty close to what we had with the mirrored compass, so pretty good.
Okay, hopefully that came through all right. Now I'll try to uncheck the video optimization. And hopefully we're back. So that is kind of the basic idea around taking an azimuth or a bearing. I also wanted to introduce the idea of triangulation. So taking the azimuth of two or more landmarks and then using those angles to draw lines on our map to pinpoint our location where those lines intersect. Accurate identification of the landmarks is imperative. I'm pretty sure I made a mistake when I was doing this example that we're about to look at. Initially, misidentified one of the hills on the map to what I was seeing on the horizon. So it is important to figure that out clearly. And if you're not sure, you might want to move to a different location where you can see better landmarks on the horizon. And it's a great idea to practice in known locations um, to, to just test it out and make sure you know what you're doing. So this next video I'm going to show you is a scenario of us traveling along the trail system in Garden of the Gods Wilderness area, just west of the observation trail. We'll get it to work.
All right, looks like from some flagging that's out here, there's an effort to reroute a portion of the trail maybe. I'm gonna go check out a portion of this. Looks like it goes up closer to the bluff line, so it might be an area of interest. Hopefully I don't get lost. Such a cool cliff. I want to see what's up on top. I'm sure I'll be fine. So, getting a little bit farther away from the trail, came up this cliff thinking the top was gonna be right up here, but guess again, there's another cliff right ahead. Huh. Well, I think we're still pretty good. Not too far off the beaten path. I'm gonna continue exploring. Looks cool. Oh boy. Sure thought I would have run into that other trail by now. Can't believe I lost my phone climbing up that cliff. Boy, I feel like I'm kind of turned around. Pretty lost. What am I gonna do? I guess one thing I can do is try to look for a landmark. I still got my map and compass, thank goodness. So maybe that'll help me figure it out. Looks like there's a clearing up here. Maybe I can get a better view and get some landmarks. Oh yeah, this should do pretty nicely. So I do have an idea generally of where I'm at. So that'll be a good starting point. And maybe I can use that saddle in the distance with the peaks on either side. Not sure if there's something in this direction. We'll have to look at the map and see if we can identify a couple landmarks. The hill on the left side of the saddle is closer to me than the hilltop on the right side. The hilltop on the right side is a little deceptive in that the tallest point on the right is actually beyond where you see those pines, so the hill is not connected there. The highest point is a disconnected hilltop a little farther away, and I'll show you what that corresponds to kind of on the map.
Okay. So kind of following from that little scenario, and taking those measurements that we found using our compass, we're going to line our compass up with the orienting lines parallel to the edge of the map. So the orienting lines are these interior lines within the compass housing, and we want those to be parallel with the edge of the map, or in this case, I actually drew another parallel interior so that I could line these up better. And I'll kind of show you a little more closely on the next slide about how this is going to look. So azimuth number 1 was at 134 degrees, adjusting for declination, that's 131. You can see the compass is set to about 131. And I found my hilltop here on the Topo map. So basically, you know that angle is going to cut through that hilltop. So you're going to line up your edge of your compass with the orienting lines parallel to the edge of the map. You're going to draw a line through that landmark. You do that 2 or 3 times and you can come up with your actual location. So we did that with the first hilltop. Then here's our second hilltop that we located. And it's at the 143 degrees. Again, orienting lines parallel to the edge of the map or the parallel that we drew in. And where those 2 lines cross should be your location. And this is where those 2 lines cross. And you can see I misread the landscape actually once or twice, and had an incorrect hilltop that I was trying to force my angles at. So that's something you got to look out for. If you're unsure, it's a good idea to add a third feature. Perhaps we could have found this hilltop and taken another angle. If we have 3, they should all intersect around about the same point. If they don't, then you know something wasn't quite right. So this is still pretty close to where I was at. I was kind of up on this cliff top. And, you know, generally in this area, it's not a huge deal because there's trails kind of on both sides of you there that you could have figured out. But if you were in a true situation of being more lost without this many trails going through, you would want to kind of go to a different spot, maybe down a little farther along this cliff edge, and try to take another reading and see if you could figure it out. So that's kind of most of what I wanted to talk about in terms of the map and compass. And up next, we're going to talk about the navigation apps. We're going to use Avenza Maps, but there are a number of other apps. I know a lot of people like All Trails. Another one I've used is Hiking Project, and there are a number of others. Some considerations you want to think about when you're using navigation apps are power, especially if you're going to be out multiple days. You might need an extra power bank. You might want to turn your device on airplane mode so it's not constantly searching for service if you're in an area without service. Offline use, all of these have options to use offline, but they all would require you to download something if you're going to navigate in an area that would be otherwise offline. So it's something you want to think about in advance. It's important to research your trail descriptions and conditions beforehand. This is in relation to really kind of any adventure plan that you have. There might be, for example, a derecho that went through an area. You don't want to go out to a place that hasn't been able to recover from those types of conditions. So looking at Avenza Maps in particular. I like Avenza for a few reasons. One is that it uses already established PDF maps, so you can find a PDF map from an authoritative source, like those USGS or US Forest Service maps, and you know they're going to be pretty darn accurate. Some of those other apps use kind of user tracks, and that isn't always your best option. They may have gone off trail or found a slightly different route. So that's something you might want to consider. Uh, One of the things you need to consider with Avenza, though, is that not all PDF maps will be georeferenced. So they won't necessarily have that embedded data that allows Avenza to locate you on the map. So they need to be georeferenced. A lot of places are realizing that people are using this app, and they will mention if their map is georeferenced or not. So that's something to look out for. One way to know for sure your map is going to be georeferenced is to find it on the Avenza Map store um, and load it from there. So once you are able to download Avenza and you open it up and you have your account, that's when you start adding your base maps. And this is kind of the screen that I see now when I open Avenza, and it shows some of the maps that I have available. I have the Shawnee National Forest bundle, which if you're exploring down here might be a good option, but as I mentioned in the um, pre-webinar materials, it's a fair amount of data. I believe it's half a gigabyte. So that might not be something that you want um, if you don't have much space in your device. So at any rate, once you get to this page, you'll click on the little plus sign, and that will give you different options for uploading your map. You can add a folder, add a collection, download or import. I usually download or import, and then that'll bring you to this page. You can get a map from the store. This is what I typically will do. Occasionally, I'll have downloaded from somewhere else onto my device, and then I'll click on this option from storage locations. But for our effort here, let's say we clicked on get a map from the store. It will automatically kind of choose your location. So in this case, I was located in Pope County here in Southern Illinois, and it'll automatically kind of generate a list of available PDF maps. And these are going to vary quite a bit. So some of them are free. There are others that you would have to pay for. Um, so instead of downloading the entire National Forest bundle, you might be able to just download one of those quadrangles. So like the Herod one is the one for Garden of the Gods that we've been looking at. So you could just download that one. It's only 11.4 megabytes versus that whole 542 for the entire bundle. Another really useful bundle that I found is the River to River Trail bundle. If anyone's thinking about that or hiking anywhere near the River to River Trail, before that Shawnee bundle came out, I used the River to River Trail maps quite frequently as well. In addition to it kind of finding your location, you can type in a location that you know you're going to be. So in this case, I typed in Johnson County, and then it gives you available kind of base maps that you could use for Johnson County, although for some reason it came up with this Missouri Atlas, and here's one you can see that they would charge you a fee for. I'm not sure why that one came up for Johnson County, Illinois. So getting into some of the options. So let's say you were able do all of that and you loaded one of those quadrangles, in this case here I have loaded the Glendale quadrangle, which includes where we're located here at the Dixon Springs Ag Center, and then also Millstone Bluff is kind of right up here to our northwest. At the bottom of the screen, you'll find various options. The bottom left is the little GPS location symbol. If there is no dot in the middle of that, it means it's not showing your location. You click on that, and then you should get this little blue symbol show up if you are located on that map document. If you're not located on that map document, you're not going to be able to click on your GPS because you're not in that area. Oops. A couple other pretty basic things that you can do are add a place mark. So this little symbol allows you to drop a little pin. You can enter descriptions of what you have at that pin and other information. You can add other map layers. So I've seen people combine this base map with like KML files. I've seen people use, like, there's a data layer for waterfalls of Southern Illinois that has a bunch of points that you could overlay within this map. And so you could have those points for all the waterfalls that you could travel to, which is a pretty cool thing to do. This little 3 dot symbol, you click on that, and there are a lot more options. You can draw and measure distances. You can record GPS tracks, navigate to a destination, find by coordinates, and so on. This is what it looked like kind of when you add a place mark. So for this example, I just added a place mark for Millstone Bluff. You can change the symbol. You can add a photograph. These place marks are useful for kind of navigating back to certain points. You could drop place marks kind of along your route so you don't get lost. You can use them to navigate to. So here's kind of as the crow flies from where I was up to that point at Millstone Bluff. In the navigation features, it shows you what your traveling speed is, the distance to your objective, estimated time of arrival, time to next. A lot of really cool features. You can also record your tracks, so where you've been traveling up to that point, how long and fast. It'll show you how long and fast you've been traveling once you start recording. You can pause it if you take a break and you don't want to record that time. You can create routes. So that earlier example just kind of was as the crow flies from the Ag Center to Millstone Bluff, but if I want to avoid private lands, I'm going to have to walk down the highway. So you can click on the create a route, and then for this example I just clicked along the road, but like I was talking about way earlier, you might plan out a route in a spot that has no trails or roads, where you might want to travel next to some water features or find an optimal route through some hills and follow that once you get out in the field. Once you create these routes, you can use it to navigate. It can give you the azimuth or bearing to different points along your route. Really just a lot of really cool functionality once you plan out your route. Like this shows you the entire length in miles. Just some general tips too. If you're going to be bushwhacking, to plan in advance, you can follow landscape features such as ridges, drainages, cliffs. Kind of those linear features are kind of easier to follow until you get more familiar. with using map and compass or the navigation apps. Um, so you can you want to drop a point maybe at your start point and periodically along your route, or use that tracking function. You can do the same sort of thing on a paper map, so just kind of document where you've been. That'll help you kind of retrace your steps if you do get lost. You do want to stay on public lands unless you have permission to navigate across private lands. And again, always let someone know where you plan to be and when you plan to return. And a good idea is to go out to known locations and practice. And looks like I'm pretty close to the end of my time, but we'll mention a couple of real quick times. I got lost out at Jackson Falls about 20 years ago before I was too into this stuff. My parents and I left the trail and got turned around, couldn't find the trail back. Ended up walking those railroad tracks for several miles. And really, the moral of that story, I won't get into it, was to always bring your map. If we had just had this real basic map of Jackson Falls, we would have found the trail no problem, but instead we had quite an odyssey. And kind of the counter to that was a trip out to Mark Twain National Forest last 2 years ago, and ended up using a navigation app where the trail ended in a dead end. It actually took us off on a unmarked trail, and we rescued another group of backpackers who had done the same thing, and they basically were little puppy dogs and followed us the rest of the way out because they didn't have that with them. So anyway, here's some of the resources that I mentioned along the way, and hopefully you found this useful and will be able to use it in your adventures. Thanks.